As a software engineer, building an API, building an infrastructure, and having a proper software, something that works for the end user, something that works very well, where users can rely on what you build. Like in my case, recently I have built a RESTful API. I chose a RESTful API because I only have a few endpoints. It will be consumed by a progressive web app. We can easily cache the HTTP request, the HTTP protocol. It's better because with a GraphQL, we would only have one single endpoint, and just for a few endpoints, GraphQL is also better. There are always pros and cons, but it's still fine. And yeah, I use TCP. It's funny because we could use like something more real time, like UDP, user diagram protocol, instead of the TCP protocol. So TCP is like HTTPS, HTTP, FPS, SSH. That's like the layer protocol. And then you have the application protocol, which is like HTTP, and TCP is like the layer protocol. And understanding all of this, even though you use AI all the time, it's always very important, because the more you understand, the more knowledge you have, the better you will be able to build something robust. So, it's like the solid principles is knowing how you can structure better your code, how you can build something scalable, like single responsibility, only one reason to change, only one responsibility, and not having one function that does way too much. We can also use dependency injection to prevent the single responsibility to be violated. And then we have like O is for open close principle. So open for extension, but closed for modification, closed for changes. And that's also something really good, really robust to yes to to be able to build something in the long term. Again, we would use dependency injection container, DIC, and then we have L. L is for list of substitution principle. So we need to have the superclass to match, the signature of the superclass, the signature of the function, the parameters, the arguments, the functions that are being thrown from that function, but also the data type we return from that function will match with the subclass. The subclass will match with the superclass. So it's important to ensure that your subclass does have the same function of the subclass. When we overload a subclass, it matches with a superclass. It's about overloading. So I have like a function name, and then I have the same function name I will define. It has to match from the subclass, from the superclass to the subclass. And then we have O is from SOLI. I is for interface segregation. That's also a good principle to write clean code. So dependency inversion is having multiple slim and thin and small interfaces, so we don't force a user to implement things they don't need. We don't force a code to implement things they don't need. Instead of having a fat interface where we force a user to implement methods they don't even need, we would have multiple small interfaces that you will be able to implement multiple of them, instead of having a fat one where you give a constraint that is not needed, whereas to implement things you don't even need, so you work something there. And that's it in the interface segregation. And then the D is for dependency inversion. So high level module code should never rely on low level module code. So if your high level module code knows, like let's say we have a database class and it has like some MySQL, like it speaks to the MySQL class directly, the low-level code. It means you violate the dependency inversion. It should instead use interfaces and abstractions. So your high-level module should never depend on the low-level module. So always use interfaces and abstractions instead. And that's pretty much it for the solid principles. You see, they are actually the principles are very obvious, like they make sense, and we understand why it's needed. Now, even though with AI, it's still very important to use the solid principles because it helps you to write better code. So solid principles is just a set of nice principles to write clean, elegant code and to be able to refactor your code better as well. And that's also very important. Dependency. And there are a lot of things you can compare and you can research on the internet. It's just unlimited. The amount of things you can look, you can do research, and you can compare as well, because it's important to not only research something and to say, oh, okay, I should do that like this. No, you should also understand why and which one is better, what solution is better. It's not because someone tells you, oh, you have to go that way. How do you know you should go that way? Maybe there's a better, more appropriate option out there. So dependency inversion, I was just looking, depends on abstraction, not on concretions. Yeah, not on concretion. That's right. And the details, yeah, the details also. So both should depend on abstraction. Furthermore, abstractions should not depend on details, and details should depend upon abstractions either. Yeah. Dependency inversion. Yeah, so you can also, log very nicely all of the errors you have on your application in a good way, in a good and efficient way. In my case, like when I built a RESTful API, I use Nest.js and I use Logger. If I want something more advanced, I would use Pino as well. I have rate limiters always set in place. I have middleware like to check the bearer token. If I don't, if I just build a RESTful API by myself with Express.js, and then I would have a cache manager where I can easily cache the most used, the most common endpoints with Redis. I would also think about pagination. Do we use offset limit pagination, or instead we use cursor-based pagination? And which one is better for us? Then I would think about other approaches I can use, I can do to think more about the user, what they need and why we need this, and how I can then make from there, from what I learned from the user, a better software. More efficient, more scalable, faster, and something that is really with really good speed, good performance, because the user doesn't want to wait too much, but also really easy to use. We see so often, maybe the application is amazing, super fast, but it's so hard to use. And we can clearly see the engineer didn't think much enough about the user. And when it's not easy to use, regardless how good the engineer was, the application is just not pleasant to use. So if the message is not user friendly, if you cannot really, it doesn't really solve the problem if it's hard to use. Always think about how I can make the best software, how I can make the best application out there, so that I will be able to provide more values, because more values is from a really good application. if my app is hard to use, I will not provide as much value as I'm supposed to. By thinking really about the user and the why I need this, and maybe I can build it differently, then you will be able to ship the best application ever. So wish you all of the best and happy product building day.